Hello again. We're going to talk about matter and motion. Physics, if one has to give a general definition of it, is the study of matter and motion. And the laws governing matter and motion were formulated by Isaac Newton a couple of hundred years ago. And he developed three laws of motion which essentially cover most of what's called Newtonian mechanics. And we're going to just briefly go over what those laws of motion are and speak a little bit about some of their implications. Okay, well, there are three laws of motion. They're called Newton's three laws. And let's just start off with the first law of motion. There's some rather wordy definitions of each of these, but we're going to summarize them in some simple phrases. The first law of motion is the so-called law of inertia, and the formal definition of it is that if you have a body at rest, say a ball bearing or something, and it's just sitting there, then this means that there are no forces acting on it. The curious thing about Newton's first law is that a body sitting at motion is a special case of a more general phenomenon, and that is that if you have a body moving at constant velocity, that body will tend to continue moving at constant velocity. Now, we need to define more precisely what velocity is. You can see that I've drawn it as an arrow. This is a notation that describes what's called a vector. And velocity is not the same as speed. It's sometimes confused with it. But velocity is essentially equal to the combination of speed and direction. And in the case of these vectors, speed is given by the length of the arrow, and of course direction is given by the direction of the arrow. Now, if you have a body traveling at constant velocity, it will tend to continue traveling at constant velocity, and a body at rest will continue at rest. And this tendency of bodies to either continue moving at constant velocity or to continue at rest if they are at rest indicates a property of matter that's known as inertia. Now, the first law of motion, Newton's first law of motion, is actually a special case of a more general law, the second law. And this law is known as conservation of momentum. And the second law, Newton's second law, simply states that a property called momentum is conserved in any kind of object that happens to be moving. Now, we have to define what momentum is. Momentum has a very simple definition. Momentum is equal to the mass of an object times its velocity. Newton called this quantity of motion, and it's simply the product of mass times velocity. If we use our notations for units, mass has units of kilograms, velocity in the SI units has units of meters per second, and so the units of momentum are kilograms meters per second. Now, whenever you have an object with momentum, it will tend to keep that momentum. As I said, this is a more general statement of Newton's first law of motion. However, if you have a force acting on an object, this is going to change the momentum of the object. If you have, for example, an object traveling at constant velocity, and you come along and exert a different force on it, then what that's going to do is it's going to tend to cause that object to accelerate. And it will continue accelerating as long as you are exerting a force on it. And so this leads to a definition of force. This is the real agenda behind Newton's second law. And we can quantify this quite easily. It has a formal definition. All of you should be familiar with some very, very simple differential equations if you've taken algebra or calculus in high school. And so what I'm going to do is I'm going to lay out the derivation of a definition of force. And so we start by saying that if there's a change of momentum, that implies that there's going to be a change of velocity. And therefore, the force is going to equal to a change of momentum divided by a change of time. This is our standard notation for a simple differential equation. We have a definition for momentum already. It's mass times velocity. So we can rewrite this by saying that momentum is equal to the change of the product of mass times velocity over the time, the change of time. And we can do a little bit of algebra on this. We know that typically the mass of an object isn't going to change. The mass is a fundamental property that doesn't change. And so we can isolate the m from this differential equation right here. And we can simply rewrite this now as the mass times the difference of velocity over the difference of time. And you should be able to recognize this right here. Change of velocity with respect to change of time is a property known as acceleration. And so the definition of force is simply the mass times the differential of velocity versus time, which we call acceleration. And this is the definition of force that comes from Newton's second law. Now, Newton's second law, as I said, is basically a statement of what momentum is and what it takes to be able to change momentum. If you have an object at constant velocity, its momentum is constant. If you have an object upon which a force is acting, the momentum will change. If you add a force in parallel with the momentum, you will increase its momentum. On the other hand, if you add a force that is working against the object's momentum, then it will tend to slow that object down, reduce its momentum. And so Newton's second law, in words, is that the net force on an object is the object's change of momentum. And the agenda behind it, of course, is simply to define what momentum is. Newton's third law is simply that a force acting on an object is met by an equal and opposite reaction. Forces in Newtonian mechanics never act by themselves. They always act in some kind of context. They act as interacting entities. And so, if you have an object that is traveling at a certain velocity, it has a certain mass, and it's going at a certain velocity, it's going to have a certain momentum. If it bumps up against some kind of a wall, for example, it's going to impact that, and at the moment of impact it's going to have a certain momentum, but that momentum is not going to go away. What's going to happen is that the force of the object against the wall is going to be met by an equal and opposite force operating against it, and what's going to happen next is that the object will recoil with equal momentum in the opposite direction. Now, that's an object against an immobile object. If you have an object with a certain amount of momentum that comes along and encounters another object sitting still with no momentum, what you will get is you get a transfer of momentum from one object to the other. And what will happen at that point is that the object here will come to rest, and the momentum will be transferred to this object being sent off in the opposite direction, but with equal momentum. The momentum coming in is equal to the momentum coming out. There are some other interesting implications of this. For example, if you have a large object that has a certain momentum coming in, and it encounters a small object that has a certain mass, let's say that the mass of this, the orange object, is equal to 1/10 of the mass of the black object. When the black object with a certain amount of momentum encounters the lighter object, the less massive object, momentum is going to be conserved in this instance, and what will happen is that the momentum, which is mass times velocity, will be transferred over to this object over here. This will have a certain mass times velocity, but of course momentum is conserved, and this means that the mass times velocity on this side must equal the mass times velocity on this side. And if the mass of this object is 1/10 of the mass of this object, this collision will send the orange object off with 10 times the velocity of the black object. Okay, so those are Newton's 3 laws of motion. Let's go over them again. The first is the law of inertia. That is, objects that are at rest or traveling at constant velocity will tend to continue to do so unless some kind of external force acts upon them. The second law of motion is essentially the definition of momentum. That is, if a force acts upon an object, it will change that object's momentum, and it will accelerate that object in the direction of the force. And then the third law is that a force acting on an object is always met by an equal and opposite reaction. And again, this is another statement of the law of conservation of momentum. Okay, well, that's all for now, and we'll see you next time.